welcome to our sinusoidal video.
Modeling video.
My name's Harrison.
I'm
This
Dahlia.
is Dahlia. Anjali's in our group, and so is Samara. Our problem was 6-93, problem 1. Lamage rode his bike over a piece of gum. Lamage continued riding his bike at a constant rate. At time t equals 1.25 seconds. The gum was at a maximum height above the ground, and 1 second later, the gum was at a minimum. If the wheel diameter is 68 centimeters, find a trigonometric equation that will find the height of the gum in centimeters at any time t.
So we'll draw our axis, and the max is going to be 1.25 seconds. And the x-axis is the time. So we can do 1.25 and then 2.25 because it's moving at a constant rate, and 3.25. And then the max is going to be, the wheel diameter is 68 centimeters. So then that'll be the max. And
then we know that the
middle will be 34. And so that'll be our sinusoidal axis. But first we'll just say that this is the max. And then this is the min. And then it goes up again to the max at 3.25 seconds. And so then, yeah, we can draw.
We know that the graph has the vertical shift up because if he's riding on a bike, the gum would never go below the ground, so it would have to shift up to accommodate for the fact that the gum height would never be negative because it's not going underneath the ground he's riding on.
Yeah, exactly. So then we can just fill it in. So these are our points. This one is 1.25, 68. This one is 3.25, 68. And this one is 2.25, 0.
We knew that this was going to be our period was 1 second because when it was at its max, our period is 2 seconds because we knew when it was at its max, it took a second to go down to its minimum. And then in order to complete a full rotation, it would have to go back up. So we knew that the period would be 2 seconds because over this time, it takes 2 seconds to complete the full sinusoidal rotation.
Yeah, so now we're gonna look at what the transformations are and stuff, so we can make the equation for it. So the vertical shift is the sinusoidal axis, and that's 34, it's in the middle. Because that's halfway between 68 and 0. And then the amplitude is also going to be 34 because it's 34 from here and 34 from here. And then the horizontal dilation is the angular frequency. And we can find that by doing an equation, which is P times B equals 2 pi.
And so in order to find our angular frequency, we'd have to use the equation, which is the period times the angular frequency equals 2 pi. So we know our period is 2 because to get from here was 1 second, and then to get to here was 1 second, and that was one full rotation. So our period for one full rotation is 2 seconds. So we plug in 2 times B, which is the angular frequency, equals 2 pi. Then we would divide by 2, and we would get
Big one.
Big 1, and we would get our angular frequency equals to pi.
Yeah. And then the horizontal shift is the phase shift, and we're going 1.25 to the right. So it'd be, yeah. And so now because we have all this, we can make the equation. So our equation, we're gonna do, it's the cosine because it's starting at the top. So A times cosine times b times x minus h plus k. And so, what's our amplitude?
Our amplitude is 34.
Yes, exactly. And then our angular frequency we just found. So that's pi. And then x. Then h is our horizontal shift, which is minus 1.25. And then k is our sinusoidal axis, or the vertical shift, which is
34. And we know that this isn't negative 34 because if it was negative, our sinusoidal wave would start down here for a cosine function.
Yeah.
And this is minus 1.25 because we're moving it to the right 1.25 from the parent function.
Yeah.
Hello. Wait. Hi, I'm Samara.
I'm Anjali.
And we're also part of this group. So, we're going to be doing parts A and B to this problem. Okay, so part A reads, find the height of the gum when Lamage gets to the corner at t equals 15.6 seconds, assuming he maintains a constant speed. So, to do this, I'm first going to plug 15.6 into the x right here. And we would do this because this graph is proportion, so we have the time and the height. So as long as you put in a time, you will always get a height out. So because x is equal to our time, it will help us get a height out. So let's solve the problem now. So after a lot of mathing, we came to our answer, which is 49.4. So this is the height of the gum in feet, right?
Now we're gonna do section B of this problem. So it is find the first and second time the gum reaches a height of 12 centimeters while Lamage is writing at a constant rate.
So we put the equation into Desmos, and this is what our function looks like.
And so to find when the gum is at the height of 12, we need to look for like specific numbers. That's why we put it into Desmos. So if we're looking on the y-axis at 12, we just go to where the function crosses that to find what time it would be at. So that's like
Basically,
0.5.
So then we go, that was about here, and then, it was like here.
Yeah, and then we have to look on, there's 2 points in a full rotation, so we have to look on the other side to find the other. Okay.
So it'd be about 1.974.
So this is the first time the gum reaches the height of 12 centimeters at 0.526 seconds, and this is the second time in the full rotation at 1.974 seconds.
Thanks for watching.
Bye!